Hi everyone, this is the notes for 4.1, graphing periodic functions. So you might have an idea of what these graphs look like from Algebra 2, but we're going to go into a lot more detail. So a periodic function is one that repeats its values in intervals. And if you think about what happens if you have like coterminal angles, that's why the values repeat, because you could just add 360 every time and come out with the same number. And it said it has a period of 2 pi because it's like adding our 360 to get those coterminal angles. We graph in radians, so that's why it says 2 pi. Okay, so let's start with our basic sine graph. So y equals sine of x. So let's fill in our table with the values that we know for sine. So the sine of 0, if you can look in your unit circle, but at 0, what's our y value? And then at pi over 2, when we get up here, our y value would be 1. At pi, we get 0. At 3 pi over 2, -1. And back at 2 pi, we're at 0. So our domain is going to be our angle measures. And we can plug in any angle that we want. So our domain would be -infinity to infinity. And our range, the numbers that we can get out, are we ever going to get out anything bigger than 1 and -1? So that would be what our range is. So the smallest we have is 1. The largest we have, or I'm sorry, the smallest is -1, the largest is 1. And like I said, the period is 2 pi. So that means to come back around, you're going to get, or you're going to have to go through 2 pi. So let's plot our points. I'm going to make 2 boxes equal 1, so it's a little bit like stretched vertically. So our first, we have 0, 0. At pi, we're at 1. At pi over 2, we're at 1. At pi, we're at 0. 3 pi over 2, -1. And then at 2 pi, we're at 0 again. So if we connect those points, this is going to be a curve, so make sure you draw it like smooth curve, not straight lines. And since it can go forever in either direction, we have to make sure we draw our ends with the arrows in the right direction. So that would be the basic graph of sine. So why don't you pause and take a minute to add some characteristics. How would you describe the graph? What do you think is going to happen every time for them? And we'll talk about those more in class. So let's take a look at cosine. We know that our period is going to be 2 pi as well because we talked about that from the front. So let's plug in some values and see if we can figure out what the domain and range is. So what's the cosine of 0? Good, you got 1. So the cosine of pi over 2 is when we'd be up at the top. So we'd have 0, -1, 0, and 1. And I was just using my quadrantal angle values there. So if we plot our points, I'm going to again make 2 boxes equal 1. So that way we can stretch a little bit and not be so smushed. And since the x-axis is stretched out a lot more, it still doesn't look exactly right. But so at 0, we're at 1. Pi over 2 is 0. Pi is -1, 0, and 1. So that gives us our 5 points to be able to connect to draw our cosine graph. So remember, the endpoints are going to, for this one, go down because your next value would be at 0 on either side. Remember, these repeat, so I could keep going, and I would do like 5 pi over 2, and then keep going. Okay, so make sure you do the ends right. I take points off for that when I grade your quizzes and tests if they're not. So our domain for this, can we plug in any angle measure we want? Yes, so our domain again is going to be -infinity to infinity. And then the biggest and smallest numbers we're going to get out are 1 and -1, so that's our range. Our graph is never going to go, for this cosine graph, bigger than that. If we multiply this cosine graph by 4, if we put a 4 out here, those numbers would go to 4 but this is like the generic basic graph. So go ahead and come up with some characteristics for cosine. How does it differ from sine? What's the same? And we'll talk about those differences and similarities in class. Okay, so as we talked about, the period stretches or shrinks the graph horizontally. So that's going to make it either go wider or shorter. So the normal graph can complete a cycle in 2 pi. And if our period changes, that means we could complete this cycle in just pi. So that means it would close in. Or if it gets bigger, we could complete it in 4 pi. So it would be stretched out longer horizontally. So the formula to find that is 2 pi divided by b. And where that b number comes from is if we have a number that's multiplying to that x, it's like they're inside the cosine. So that's where the b is, and that is what stretches your graph horizontally. So your period is a horizontal stretch. So our amplitude is our vertical stretch. So that would be a number that's multiplied to the cosine function. So out in front, which is kind of like what I just talked about. Oh, I wrote B, it's A. On the other one, like if we multiply it by 4, it's going to get taller. Okay, so the amplitude is the number that the sine or cosine is multiplied by. So whatever is in front of the sine or cosine that's being multiplied is your amplitude. Okay, so I wrote out our steps to graph at the bottom. So let's try our first example. So like it says, the first thing we need to do is find our period. So our formula for our period is 2 pi over b. And remember that this is a and this is b. This would be 2 pi over 2, which is pi. So that means a whole complete cycle of our cosine or our sine cosine graph is going to be completed in pi. So remember, the shape of your cosine graph started at the top, went down, and went back to the top. So instead of finishing at 2 pi, we're going to shrink that, and it's going to finish at pi. Okay, so that means that instead of going from 0 to 2 pi, we're going to go from 0 to pi. We're completing the whole thing in just pi. So step 2 said to divide that interval into 4 parts, because that would be what your change is here to get to your next x value. So our period was pi, and we're going to split that into 4s, so that would just be pi over 4. So that means to go to our next x value, we'd add pi over 4. If we add pi over 4 again, we'd have 2 pi over 4. If we add pi over 4 again, we get 3 pi over 4. So I like those numbers reduced, but sometimes it's helpful to leave them in there as like the original fraction so you can see what you're adding each time. Okay, so to find our x or y values, we have to take a look at our normal y values. So what's happening for normal cosine? So if you go back and look, we start at 1, we go down to 0, go down to -1, back to 0, and back to 1. So those are our normal y values. 1, 0, -1, 0, 1. And that's without any amplitude or any stretching happening in your graph. But for this one, we have an amplitude of 2. So that means it's going to be stretched out on either side of like the center by 2. So we would take these numbers and times them by 2 to get our actual y value. So we'd have 2, 0, -2, 0, 2. And those are going to be the points that we plot on our graph. So if you look at our graph, I didn't put any numbers on the axes or anything, so we're going to have to decide where we put them. Okay, so for our y-axis, I'm just going to go up by 1s. But remember, on our front, it's not going to look stretched out because on this one we went we made it go by 2. You know, 2 boxes was equal to 1. So don't get confused that it's not bigger. We're changing our scale. As far as the x-axis goes, most of the time I will make each box be equal to what our interval is, because that makes it easier when we have to shift our graphs. So each box will be pi over 4. So that'd be pi over 4, pi over 2, 3 pi over 4, and pi. So from there we would just plot our points. So at 0, we're at 2. At pi over 4, we're at 0. At pi over 2, we're at -2. 0 and 2. So from there you would just have to sketch the curve. Remember to make sure your endpoints are pointed in the right direction, and they go on forever, so you should have arrows. Okay, very good. So why don't you pause the video, try to do the same thing for the next one. Remember that this one is sine, so your y values are different with sine. And then when you come back, we can go over the problem. Okay, so for this one we got that our period was 2 pi over 3. So that means our graph is going to complete its whole cycle from 0 to 2 pi over 3. If we divide that by 4, which is like timesing by 1/4, we end up with our interval being pi over 6. So we're adding pi over 6 each time to get our x values. So the normal y values for cosine is 0, 1, 0, -1, 0. But we have an amplitude of 3. So we would take all those numbers and multiply them by 3. Okay, so if we take a look down at our graph, I plotted our those original points right there. I had to make the y-axis be just 1 since we had to go all the way up to 3, and each x box was pi over 6, and that's what we would get. So I graphed 2 periods of it for you to see that we could keep going. So if I wanted another set of cosine, I could keep going, and I could keep going further and further, because once you see the pattern and you will have the basic graph laid out, you can go forever in either direction. So the next thing after this cycle would be we start back up at 3. Okay, so we have 0, 0, and then we have 3, and then we go back to 0, and then we go down to -3, and then we go back to 0. So that would be another period of this graph. So this would be 3 periods. So the period, remember, is how long it takes to complete a cycle. So each time we complete a cycle, that's like having another one. Okay. So why don't you pause and try our last example, and I will show you what it looks like when you come back. Okay, so here's our table for this one. I like these kinds where it your b value is a fraction, because then you end up having a whole number for your period, and then you have no fractions in your x values. So we had 0 pi, 2 pi, 3 pi, and 4 pi, because if our period's 4 pi, we divide it by 4. Our interval, or the amount we're increasing for x values, is just pi. Our amplitude is -4, so if we multiply those normal sine values by -4, we end up flipping our graph upside down. So instead of starting at 0 and going up, it's starting at 0 and going down, and then you can see the rest of the sign there. Okay, so that is it. Remember to write down any questions you had, and we can talk about them in class tomorrow.